A child's experiences during the earliest years of life have a lasting impact on the architecture of the developing brain. Genes provide the basic blueprint, but experiences shape the process that determines whether a child's brain will provide a strong or weak foundation for all future learning, behavior, and health. During this important period of brain development, billions of brain cells called neurons send electrical signals to communicate with each other. These connections form circuits that become the basic foundation of brain architecture. Circuits and connections proliferate at a rapid pace and are reinforced through repeated use. Our experiences and environment dictate which circuits and connections get more use. Connections that are used more grow stronger and more permanent. Meanwhile, connections that are used less fade away through a normal process called pruning. Well-used circuits create lightning-fast pathways for neural signals to travel across regions of the brain. Simple circuits form first, providing a foundation for more complex circuits to build on later. Through this process, neurons form strong circuits and connections for emotions, motor skills, behavioral control, logic, language, and memory during the early critical period of development. With repeated use, these circuits become more efficient and connect to other areas of the brain more rapidly. While they originate in specific areas of the brain, the circuits are interconnected. You can't have one type of skill without the others to support it. Like building a house, everything is connected, and what comes first forms a foundation for all that comes later.
As for every single one of us, learning something new means rearranging the way her brain works. Our brain has an astonishing 100 billion neurons, or brain cells, all connected together. Learning is about creating and strengthening pathways through these neurons for impulses of electricity. But between each and every connection in our brains, there's a tiny gap called a synapse. For any of us to learn something new, the electrical signal has to jump across this gap to continue its journey. The gap between the two brain cells is tiny, but that doesn't mean it's straightforward for a signal to get from one side to the other. For us, it's like crossing a deep ravine. And getting from one side to the other should tell us something about the way we learn. The first time a signal crosses from one brain cell to the other demands the most effort, and it's the same when we cross our ravine. The first trip across is the hardest. Having crossed the ravine once, the journeys across get easier and easier. And a similar thing happens when we learn something. To start with, learning is difficult. As the signal crosses the gap between the brain cells again and again, we establish a more solid pathway. Sorry about that. By the time we've made the crossing over and over again, it becomes effortless. We can do it whenever we like. we've finally learned something.